Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have a power series right here, and we have to find the radius of convergence of this power series. Now, let me remind you first that whenever we have a power series, there are three possible radius of convergence that it can have. And therefore, it can have three possible interval of convergence as well. So suppose the power series is an x minus c to the n, the general form, which means the c is the center. Okay, then there are three possible cases. One is that this power series converges only at a single point, and that is at the center of the series. See, for a given power series, it will always converge at that point, for sure. Okay? Now the question is, are there any other place that it will converge? So this is the first extreme case, that it is only converging at C, and all the other places, for all other x values on the real line, the series will diverge. So where is the interval of convergence? So in which interval does it converge? Well, there is no interval. There's just that one single point, which means the radius, in this case, if you call r to be the radius of convergence, it's just 0. There is no radius either. Okay? Now the second possibility is the other extreme, which is the series will converge everywhere. The entire real line is the interval of convergence. So that's the case. So C is the center still, and it converges everywhere. So what is the radius? See, the radius is, so the interval of convergence is negative infinity to infinity, and radius is half that interval, so radius is infinity. Now there's a third possibility, which is an intermediate stage, and that is when it converges, when the series converges in an interval with C being the center of that interval. So some interval it converges, and that interval has radius r. So in this case, r is not 0, not infinity, but something in between. So r is between 0 and infinity. So only one of these three things can happen given any power series. So question is, what's happening to the one that's given to us? Okay, so we have to figure out which of these three is happening. And for that, usually you can apply this test for any power series to figure out its radius of convergence, and that is the ratio test. So use ratio test. Okay. So recall, for ratio test, we have to find the ratio between the nth term and the n plus 1 term. Now what is the nth term? It's whatever is given, this expression. So an is negative 1 to the n, x to the n over n. Now looking at an, let's figure out its next term, an plus 1. And how do we figure that term? You just have to plug in n plus 1 wherever you see n. So an plus 1 will be negative 1 to the power n plus 1, then x to the power n plus 1 divided by n plus 1. Remember, you're changing n, not x. Keep x as it is. Only n changes. Okay? Now, for ratio test, we have to take the limit as n approaches to infinity of absolute value of the ratio an plus 1 over an. Okay? So let's write everything down. Keep the absolute value is very, very important, particularly for power series. You will see absolute value is very important. Okay, now look, there will be a fraction in the numerator, this entire n plus 1, and a fraction in the denominator. So we can rewrite them as one fraction. How? We keep the numerator fraction as it is. Okay? So the whole thing, write it down for an plus 1. And then the denominator fraction will flip. So the an, instead of writing an, you just flip it and then write. So it will be multiplied by n over negative 1 to the n, x to the n. Okay? Now, let's see if we can cancel something. Look, the negative 1 in the numerator and denominator, you can cancel that. So there's negative 1 to the n plus 1 and negative 1 to the n. So 1 extra negative 1 in the numerator. So let's write that now. Also, notice the x to the n plus 1 and x to the n. You can cancel that as well. So there's an extra x in the numerator. The rest will cancel. And then we will just have n over n plus 1 as it is. Okay. Now, what should we do about this absolute value? First of all, the negative 1 inside the absolute value will have no meaning, right? Absolute value will make everything positive. So we can get rid of negative 1 right away. We don't need to write that down. Now, what about this x? Now, x is a variable. It can be any real number. We don't know what real number x has, right? So we cannot ignore the fact that x can be negative as well. So keep in mind, very, very important, you have to keep absolute value against x because it can take negative values, okay? But n will be positive. We know that. N is starting from 1. N is approaching to infinity. N will never be negative. So we don't need absolute value against n over n plus 1. So you can keep that by itself. All right. Now, another very important step. Look, this limit is over n. N is approaching to infinity. So x is a constant compared to that. And so you can pull absolute x outside the limit. So this is absolute x, limit of n over n plus 1. And now how do we evaluate this limit? We use the similar trick that we have done before. We divide both numerator and denominator by the highest power of n, which is 1. So you divide by n in the numerator and by n in the denominator. And so we will have, in the numerator we have 1, denominator you separate n over n plus 1 over n. So 1 plus 1 over n. Now as n goes to infinity, this 1 over n goes to 0. So this guy will approach to 0. And so you will have absolute x times 1 over 1 plus 0. And this is just 1. So your answer is absolute x. Now don't forget what we're doing, right? We're applying ratio test. What do we know about ratio test? That whenever you take the limit of the ratio, if that is less than 1, then the series will converge. So we know this less than 1 implies series converges. And so this particular inequation will give us our interval of convergence, right? Okay, so we have, let's come back here. We have converges if absolute x less than 1. Now, do you know how to solve that? You remember, this means x lies between negative 1 and positive 1. So that's our interval of convergence. So what does that mean? Now, look at this series. What is the center of this series? See, it's just x to the n, which means center is 0, right? So it's very easy to see with a picture. Your center is 0, and our interval is between negative 1 and 1. So what is the radius? Radius is right here. It's 1 unit. So we know that the radius of convergence is going to be 1 for this power series. So that concludes this problem. Thank you.